my goodness. For the very last time ever, who's my favorite student? This is the last one. So a motor is connected to 240 volts and it draws a current of 30 amps when it's prevented from turning. This is an important phrase to note because part A wants the resistance of the armature coil. We said this. V back was equal to your source voltage minus that. When it's not turning, what's your back voltage exactly as a number? So when it's not turning, you get 0 equals your source voltage minus that. In fact, really, you can now get the R by itself, plus that over to that side, and you get a version of Ohm's law, except we just wrote it that way. Why did we use a lowercase r? To indicate we would like a tiny resistance in the armature. We don't want the armature glowing red hot. They want the resistance, so the resistance is going to be the EMF divided by the current. It's going to be 240 divided by 30. This is an 8 ohm resistor. If you got that, 3 out of 3. Otherwise, I would give you a half mark if I saw that, a half mark if I saw that, a half mark for that, half mark for that, half mark for the numbers, and a half mark for the answer. What about at normal operating speed? Okay, now it's pretty plug and chug. V back equals the EMF minus I times R. It's going to be 240 minus, when it's turning, it pulls 3.2 amps and 8 ohms. It's going to be 240 minus 3.2 times 8. And I get, is it 214.4 volts? I'll write 214, but I would take 214.4 volts. If you got that, 4 out of 4. Otherwise, I would give you 1 mark for that. I would give you 1 mark for the numbers, and I guess I would give you 2 marks for the answer for it to be worth 4 marks. An ideal step-up transformer's primary, okay, so here is N primary, here is N secondary, here is V primary. They want V secondary. So N primary over N secondary equals V primary over V secondary. If I stick in my numbers, it's going to be 50 divided by 1500 equals 120 divided by the mystery voltage. When I cross multiply, I'm going to get that equals 1500 times 120 divided by 50. Or you could have done it algebraically first, no matter what. I'm fine with that. We're going to get 1500 times 120 divided by 50, 3,600 volts. Is that correct? If you got that, 2 out of 2. Otherwise, I would give you a half mark for that. I would give you a half mark for that, a half mark for the numbers, or if you rewrote it algebraically, and a half mark for the answers. Oh, now they want the current. Okay, that's going to be N primary over N secondary equals, not N, Mr. Dueck, I secondary over I primary. It's going to be 50 over 1500 equals 3 over I secondary. Addie, I noticed that this equation up here and this equation up here look really similar. It's just a different variable. So I said, you know what? I secondary is going to be 1500 times 3 divided by 50. 90? Oh, it's one in the primary current, Mr. Dueck. And I labeled it wrong. I put it in the right place, I think, but I labeled it wrong. Because primary is on the bottom, is it not? Yes. So it'd be that times, okay, I did that right. Now what's the answer, Mr. Dueck? After that slump, you better recover. 1500 times 3 divided by 50. Is the primary current 90 or 9? 90. 90 amps. A step up current, sorry, a step up transformer, more coils, more voltage, lower current. So higher number of coils on the secondary, higher voltage on the secondary, but you'll get a lower current. In terms of part marks, again, I'd give you probably a half mark for that, a half mark for that, a half mark for the numbers, and a half mark for the answer. A coil of wire is moved into a magnetic field as shown below. What's the direction of the induced current? So there's two ways to do it. One way is to look at a single proton right there. Which way is that proton traveling? Since it's part of the coil, which way? Yeah, to the left. So I could point my thumb to the left. This proton is about to hit a magnetic field into the page. This proton, right when it gets to where this arrow is going to get forced in that direction. So that's anti-clockwise. Or I could use Lenz's law. As we move into here, we're getting an increasing into the page. What would resist an increasing into the page? A decreasing into the page, or an out of the page, an increasing out of the page. I could point my right thumb out of the page, and I also curl my finger in the correct direction, because Lenz's law and right-hand rules still have to work. It is anti-clockwise. B, here, I would use Lenz's law. Daniela, what's the final direction of the magnetic field? What's the after picture direction of the magnetic field? What's going to resist a final magnetic field out of the page? A final magnetic field into the page, and that gives me in this direction, clockwise. Yes, is that correct? No, yes, need some nod. Nod's good. Magnetic field strength is that. What's the magnetic flux? So magnetic flux is B times A. What's B? 1.2. What's the area? It's a rectangle, so it's going to be length times width. That's going to be the answer. It's going to be 1.2 times 0.08 times 0.12. I get a magnetic flux of 0.0115. 0.115. What's the units for flux, for magnetic flux? Yeah, the units for all flux is lines per square meter, but lines. Magnetic flux is Webers. Okay. So what, you want 0.012? I'd take that, but go to 3 sig figs. 2 marks in terms of part marks. I'd give you, I think, 1 mark for that, half mark for the numbers, and a half mark for the answer. What's the strength of the magnetic field? Now they've given me the flux. I guess magnetic field is going to be flux divided by area. It's going to be flux 0.015 divided by, now this time they didn't give me the area, it's a circle, divided by pi r squared. It's going to be 0.001, no, 0.015, not 2 zeros, Mr. Dueck. 0.015 divided by pi times 0.075 squared. 0.015 divided by bracket pi times 0.075 squared. And I get, is 0.849 correct? Units for magnetic field strength. Teslas. And this one, I guess I only made 1 mark, so I'd probably go like this. Half mark for the equation, half mark for the answer. Ooh, number 7. Find the induced EMF. Okay, when I have a speed, the induced EMF is B It's going to have a magnetic field of Mr. Dueck, of 1.2. It's going to have a length of 0.25, and it's moving at 8.9 meters per second. So the voltage induced on top, between the top and bottom of this bar, is it 2.67? Is that correct, or did I make a typo?
Yeah.
People nodding?
2.6.
Volts. I would go 1 mark, half mark, half mark. Now it wants the current. Well, I just found the voltage. I bet you I'm going to go, not R, I equals V over R. Although since it's an induced voltage, we traditionally use an EMF symbol. It's going to be 2.67 divided by, what did they say the resistance of this was? 0.025. So I'm just going to go answer button divided by 0.025, and I get 106.8 amps. 107 amps would also be just fine and dandy. For 2 marks, 1 mark, half mark, half mark. Now they want the magnetic force on the strip. Okay, that's going to be Bill. That's going to be the magnetic field, which was 1.2. The current, which is 106.8. And the length, was the length 0.25? It's going to be 1.2 times, answer button, times 0.25. And I get a force of 32.0 newtons. Is that correct? That's the magnitude. Now, what's the direction? Let's see. Here's my proton originally. Originally, it's moving to the right. Which way will that proton feel a force if the region is out of the page? To the right, out of the page. It'll originally feel a force down, but now the proton is also moving down the page. So I have to repoint my thumb down the page, magnetic field out of the page. The net force is going to be that way. I'll call that direction left. And of course it is. That's Lenz's law kicking in, saying, look, whatever you're trying to do, nature is going to oppose it because of conservation of energy. You'll feel something trying to slow you down. For 3 marks, I would probably go something like this. 1 mark for that, half mark for that, 1 mark for the magnitude, and a half mark for the direction. I don't know, something like that. Can you give yourself a lovely score on this take-home quiz, please, out of whatever this quiz is out of? What's it out of, Mr. Dueck? 23. Give me 1 second. Hang on. Let me pause.